Good morning, students. This question number 73. I am repeating. Two charged spheres of radii A, comma B are connected with a metal wire. Find the ratio of electric fields on the surfaces E and EB. Before connecting, electric potential charges may be different, but when you connect with a metal wire, charges will travel from sphere of high potential to low potential, compulsory based on only potential difference, not because of other reasons. Only because of potential difference only, charge will travel from high potential to low potential, and after all of it travels is both get the common potential. So when two metal spheres are connected, then both get a common potential. V common is same for both. So E equal to V by R is the relation we have. We have the E and B relation for the first sphere. E equal to V common by A. Second sphere EB is equals to V common by B. So if you take the ratio of these, that means electricity is inversely proportional to radius because E is constant. So E is proportional to A. Take the ratio of this E and EB, you will get as V by A. Reverse ratio will get E electricity is inversely proportional to radius. Or you can say inversely proportional to radius if V is constant. Next 74. Question number 74. Electron is accelerated. An electron is accelerated through a potential difference of 200 volts. Through a potential difference of 200 volts. Electron is accelerated through a potential difference of 200 volt. If E by m for the electron B is 1.6, this E by m is nothing called a specific charge. Charge to mass ratio, or charge per unit mass, is called as a specific charge. If E by m of electron is 1.6 into 10 to the power of 11 coulomb per kg. Coulomb per kg. Find the velocity recorded by the electron. Coulomb per kg. Find velocity gained required by the electron. Means gain means what are the initial velocity is there, no, that is changed to new velocity. So whatever work is done by this electric field and due to the potential difference is converted to kinetic energy. So what is the relation between the potential difference and the work done is nothing but equal to work done of energy is nothing but equal to potential equal to work by charge. So potential work becomes equal to what? Charge into potential difference. So what I get here is answer work W is equals to charge into potential difference. The charge you are moving into potential difference. But charge you are moving is nothing but equal to electron discharge. It is electron. So this becomes equal to E into V or E into W we can take. So I am writing this as the potential difference is delta V. We generally take delta W we can take. I am writing this as equals to QV. V itself is potential difference of taking the symbol. Delta V I am taking as a V. So actually generally we take V as a potential only, but for battery at some cases no. Delta we can replace it to V for comfort purpose. Because this Q becomes is what is equals to E into V. Whatever work is done is converted into changing kinetic energy. So work is also equal to delta kinetic energy change, which is equals to half m V square minus half m U square. When they don't mention about the initial position, I will start from rest. So this is nothing but equal to increasing kinetic energy from rest to M. So half m V square minus half m U square. Okay, or delta E. Kinetic energy change is nothing but half m V square only. V we have to find out. Careful with the symbols, potential and velocity. V symbol only we take. So I will change the potential symbol as V naught to avoid the confusion with the velocities. And capital is smart also you can take the zero. So what it is V naught is 200 volts. Exactly potential difference. 200 volts. Delta V naught. Q equal to E is here. Change kinetic energy is half of V square. V is velocity. M is mass of electron. Applying this, what you get? EV naught is equals to half m v square. We want a v relationship. So velocity is v equal to 2 into E into v naught by m under root, because it's v square. In this E by I am already given for you. What is E by M? Specific charge is 1.667, but 1.67 is actually, but value whatever in the question that you have to use. 10 to the power of 11 positive value coulomb per kg relation, because charge by mass coulomb per kg. You need to remember the specific charge electron, but here proper value is given, that you have to use. Is equals to under root of 2 into E by M substituted. What is E by M value? E by M is 1.6 into 10 to the power of 11 coulomb per kg. So this is 1.6 into 10 to the power of 11 into product difference is 200. So V becomes equal to 2 into 2 is 400 units. 400 and we can fix as 10 to the power of 2. 1 0 decimal cancels. So we will get as 2 into root 16 is 4. 1.6, no, this decimal 1.6 to 1 0 cancels. So what is left out is 1 0 only. 1 0 means 12. You will get as equal to, let's write this point again. 2 into 2 is 16 into 10 to the power of 11 into 2 into 10 to the power of 1 under root. I modified this only by removing the decimal. So remember 10 to the power of, this is 16, root is 4, 2 into 2 is 4, root 4 is 2, 10 to the power of 11, 10 to the power of only 10 is there. This power is 1, 10 to the power of 12 you get, 10 to the power of 12 root is 10 to the power of 6. So this velocity becomes equal to 2 into 4 into 10 to the power of 6. That is 18 into 10 to the power of 6 meter per second. We need to take this here. U is the starting compressive element. Otherwise, change in velocity we can consider. If they give already initial velocity, no, you have to consider v square minus u square as the difference in the kinetic energies. Next 76. I am checking here. Others, whatever I am leaving, if no, in between hints are given, you can go through that. 76. Question numbers with the star points are very, very important. That means there are multiple times repeated questions there. Next, charge 6, 12, 24 nanocoulombs, all are positive, are placed in the corners of a square of side 10 root 2 centimeters. What charge you have to put at fourth corner, so that the potential at the center of the square is 0. Here charges 6, 12, 24 nanocoulombs, it is 10 to the power of minus 9 nano means, are at the corners of a square. Of a square of side 10 root 2 meters. Find what charge you have to put at the fourth corner. Find the charge to be placed at the fourth corner, so that potential at the center of the square is 0. The potential at the center of square is 0. You are given 3 charges out of 4 corners. Charge is a scalar, potential is also a scalar. Q1, you can take any clockwise or anti-clockwise. For potential purposes, does not matter whether you clockwise or anti-clockwise. Electrical direction is required now, so you must take specifically clockwise, anti-clockwise. That charges nothing like that. As a potential purpose, you can take no scalar only. You don't need to bother about it. Direction is required means you need to be careful. Which is the x-axis, which is the y-axis, or clockwise or anti-clockwise. The specific case for the electric fields, vector purposes. For the scalar cases, no. Q1. This is Q2. Say Q3 and Q4. You can take ABCs. Q1 is 6 nanocoulombs. 6 into the power of minus 9 coulombs. Q2 is 12 nanocoulombs. Q3 is 24 nanocoulombs. Only 3 are given. Q4 you have to find out. So that the potential at the center, this O I will take, VO equal to 0. Each side length is given. Side A is 10 root 2 meters. A or root L, you can take your choice. This is also going to be A, and this is also A, and this is also A. All sides equal. So what is the hypotenuse becomes this? A diagonal. This is a rectangle triangle. This becomes equal to A root 2. But we don't want. We want half of that. Center to corner. So I will take this as R, and R. What becomes this? Diagonal is 2R. 2R equal to A root 2. Diagonal of square is the answer. And diagonal of the square is 2R. Is equals to this A and A. This becomes equal to A root 2. A root 2. We want the distance from center to charge to center. From corner, every corner, each one, to center of the square is R is equals to A root 2 by 2, which is A by root. But A is given already for you. What is A? 10 root. Therefore, R is equals to 10 root 2 by root 2, which is equals to 10. This part calculation you must save the time. Directly, generally, most of the problem 10 root 2 given means sides for the square of this will be 10. That you will do. Next is this one part. Potential at the center. Total potential at center is V0 equals to V1 plus V2 plus V3 plus V4. In this also, you have to save the time. You must able to write the direct formula. Why? Because here distance are same. R is same. You can take out common. Potential is 1 by 4 pi 2. 1 by 4 pi epsilon into Q by R is the potential. So R is same here. Distance from center to corner is same. So proportionality constant is same. So what we left out is 1 by 4 pi 2 Q by R. No, R is same. Q is different. So Q1 plus Q2 plus Q3 equals to 1 by 4 pi epsilon naught into R. Here in the bracket Q1 plus Q2 plus Q3 plus Q4. But what is given is V naught equal to 0. Potential to the center is 0. So this is supposed to be equal to 0. It is given. It is given. When it is given 0, no, this 1 by 4 to take it to class multiplication 0. So what is left out is only Q4, Q1. Q4 becomes 0. This all becomes is minus. Therefore, Q4 is equals to Q1 plus Q2 plus Q3 of negative charge. Now just substitute the values. So for such these problems, just go, we must look to jump directly to this. Okay, sum of the charge is equal to 0, which is equals to minus of Q1 6 into 10 to the power of nanograms I am taking it out, plus 12 plus 24 4 into 10 to the power of minus 9 coulombs. So Q4 becomes equal to negative sign charge, it becomes 12 to 24 becomes equal to 36 plus 6 42 minus 42 minus 42 into 10 to the power of minus 9 coulombs or 9 coulombs. Potential is 0 means just remember that Distance is same, potential is 0. Sum of the charge is equal to 0. That condition. Next question is 77. This is actually basic concept question also. What is the voltage to move a charge q around in a circular path of radius r with the charge around with the charge q at the center? Find the work done to move charge q around charge capital. Okay, they want that as in circular path, the center charge is capital. Around charge q in circular path of radius r. So we are taking the source charge q here, this is capital Q. Plus or minus does not matter. You are taking a circular path from the other charge q. Distance equal to r. This charge is q. So what is the work done? At a given distance r, what is constant is potential is constant. At a given distance r, v is constant. So this forms the eq potential surface. That will call it means v is constant. Whenever the v is constant, what is always a 0. So given distance r, this point is a concentrated point. We need to remember that. Water to move the charge any distance on the equivalent surface always 0. Potential difference is there means work is done. When potential difference is not there, work is not done. That means what? You are going from one point to other point. Everywhere the potential is same. What is the potential difference? 0. When V is 0, potential work done is 0. One way. Other way is electric field. Electric field is always perpendicular to the direction of electric field. Positive is there. Direct away from the radius. Radial. Electric field is radial. So if I take like this is a charge q. Also negative does not matter actually here. Electric field is direction. Velocity is always another time. What is this angle is 90 degrees. So displacement what I take, displacement is always perpendicular to electric field. For also negative whatever I take. In such cases also work equal to force and displacement into cos theta f dot s. Like that if you take also work done is 0. So at given distance, answer work done is equals to charge you are moving into potential difference. But V is inversely proportional to V is equals to Q by 4 pi epsilon to R equal to constant. Since R is constant and Q is also constant, source charges. V is constant. The viability is equal to given surface, circular path becomes equal to surface. Given circular path is equipotential surface. So what done? W equal to surface, V is constant. W equal to this charge is moving into V minus V. Two different points okay, delta V is equals to 0. V is equals to constant. So delta V potential difference equal to 0. Therefore work is equals to Q into delta V. We can you don't have to work out it, you have to remember that. Okay. You will get the similar case in the magnetic field, but in the magnetic field work is done only in the electric field. The charge is moving around, the other charge is equal distance. One is always a 0. Like electron is revolving around the nucleus. Nucleus has a positive charge. Electron distance is radius constant. If you are taken, then the work done is always a 0. Electron is not doing any work, or electric field is not doing any work to move in a circular path around the other charge. Why? Because potential is constant, or electric field is perpendicular to displacement. So concept that will come to surface words are we have discussed before, you have to remember that. Next 78. Next 78. Two charges Q1 12 nanocoulombs, Q2 minus 12 nanocoulombs, means that forms a dipole. Are placed 10 centimeters apart. What is the potential point? 6 centimeters from Q1. Two charges Q1 is plus 12 nanocoulombs, Q2 is minus 12 nanocoulombs. When you have two charges separated by equal and unlike charges separated by some distance, that forms an electric dipole. Are placed 10 centimeters apart. Are placed 10 centimeters apart. Means the separation between these two is 10 centimeters. Are placed 10 centimeters apart. The potential point 6 centimeters. Find the potential. Find the potential at point 6 centimeters from Q1. From Q1 on line joining the charges. On the line join two charges. I think they asked quickly. To be between the charges, yes. Between charges. You can take even outside also, but your question is supposed to be between the charges. I am taking here Q1, this is Q2. Equal and like dipoles. Center is 0. Total separation is how much is 10 centimeters. 10 centimeters means 5 centimeters and 5 centimeters. Remember, potential at the middle point of equal and unlike charges is always 0. For dipole, potential at the center point is always 0. But you are not asked 10 center point. You are asked at 6 centimeters. So I think this is not center here point. Somewhere here from Q1 6 centimeters. So this is going to be R1 and equal to 6 centimeters. Remaining distance how much becomes is 4 centimeters. Total R equal to 10 centimeters. This is R1 plus R2. You are asked to find out here total potential V equal to how much. So V at the point V total is nothing but equal to V1 plus V. I want V at this point total. Answer. Q1 is 12 nanocoulombs. 12 into 10 to the power of nano means 10 to the power of minus 9 coulombs. Q2 is minus 12 nanocoulombs. Minus 12 to the power of minus 9 coulombs. Next for total separation R1 on the diameter that I am taking because R is not required. R1 is 6 centimeters. 6 into 10 to the power of minus 2 meters. R2 is remaining point, that is 4 centimeters. R1 plus R2 is R equal to 10 centimeters. That's 4 into 10 to the power of minus 2 meters. So conversions you better do near the question. In the question paper only for marked exams. Here only write 12 into 10 to the power of 10 to the power of minus 9. Here only you write like that. It will be here 10 into 10 to the power of minus 1.1. 6 centimeters. That's not accurate, but its problem means 6 into 10 to the power of minus 2. Here only the question will be, if you write that, you can save the time. You do not write, spend the time of writing here. Next, total potential at the center. Not center, the given points. Potential at the given point is V total equal to V1 plus V2. V1 is nothing but equal to Q1 by 4 pi epsilon into R plus Q2 by 4 pi epsilon into R2 is the potential. At the midpoint potential is 0, but it is not a midpoint, so some potential will be coming. That can be positive or negative. So V total becomes equal to 1 by 4 pi epsilon take out common. That becomes 9 into 10 to the power of 9. 9 into 10 to the power of 9 into Q1 by R1 plus Q2 by R2, which is 9 into 10 to the power of 9. Q1 is on which is 12 into the power of minus 9. So I am just taking the values 12 by R1. R1 is 6 centimeters plus Q2 is minus 12. That is minus 12 by R2 is 4 centimeters into numerator nanocoulombs 10 to the power of minus 9. Denominator is centimeters 10 to the power of minus 2. Okay, this will be 6 2s are 4 3s. 2 minus 3 is minus 1. Negative comes from now. The result is V total equal to minus 9 into, this will be cancelled. 10 to the power of minus 9, no, plus 200. So the result is 900 volts. This is question number 18, you can easily work out. 17 and also already I gave you before. I will give the hint work equal to QV equal to half mv square. Water equal to charge into potential equal to half mv square. Velocity get find out. Similarly, 18th question also you can work out easily. 4 charges are given to 4 quarters of the square. Center potential they ask you. That equal to 0 plus 80 plus 80 plus 0 easily get it. 81. Charge Q is present at each corner of a cube. Question number 81. It is a cube. Each charge is same. Charge of Q is placed at each corner of Q of side. It is not a square, 3-dimensional of side A. Charge is Q, side length is A. Find potential center of Q. Find potential means total potential at the center of Q. So Q, how many corners are there for Q? Six sides will be there. How many corners are there in the cube geometry? 8 front to 4, back side 4. So we have all 4 corners each side, means total 8 corners. Our charges Q, 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 Q. Total potential in center is sum of the all potentials. What is the distance from center to any corner? Center to any corner, you could take this is what we call as a body diagonal. Half of that is equals to R we have taken. Okay, each side length is A. Each side length is A. Okay, the body diagonal length, the total length of the body diagonal. Side is cube, you are taking. Side of cube. Body diagonal. Body diagonal means if you take the room of this corner to that corner, through the center. Diagonal, not face diagonal. Face diagonal means each side is face diagonals. It's a body diagonal. A and A. For face diagonal it becomes equal to square only. Square means this rule, if you are taking this is face diagonal. A root 2. Okay, but body diagonal becomes what is? This is a face diagonal.